This lesson is congruence in right triangles. The goal is to prove right triangles congruent by using the Hypotenuse-Leg theorem. The standard is similarity, right triangles, and trig number 5. By the end of this lesson, you should understand that you can prove that two triangles are congruent without having to show that all corresponding parts are congruent. In this lesson, you will prove right triangles are congruent by using one pair of right angles and a pair of hypotenuses and a pair of legs. In a right triangle, the side opposite the right angle is called the hypotenuse. It is always the longest side of the triangle. The other two sides, the ones that are touching the right angle, they're called the legs. And as this says, the right angle always points to the hypotenuse. The hypotenuse-leg theorem states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So if you look at those two triangles, if triangle PQR and triangle XYZ are right triangles, then PR is congruent to XZ, and PQ is congruent to XY. Then the true triangles are congruent. To be able to use the hypotenuse-leg theorem, the triangles must meet three conditions. The first condition, there are two right triangles. Number 2, the triangles have congruent hypotenuses. And the third one is there is one pair of congruent legs. Are the two triangles congruent? If so, write the congruence statement. Number 1, I have two right triangles. The hypotenuse on both is 10, and the leg measures 6. So we know that they are congruent. So I know that angle CBA is congruent to angle DEF. On the next one, I have a right triangle there, a right angle, which means this one is a right angle by the fact that these are vertical angles. And we have the hypotenuse is congruent, and one leg is congruent. Therefore, triangles LPM is congruent to triangle ONM. Look at number 3. I have two sides that are congruent, but nowhere does it show that these are right triangles. So I cannot prove that they are congruent. In number 4, I have each triangle has a right angle. We have one leg, and we have that is the hypotenuse, and because it's the same line, then it is congruent. So I have triangle XVR congruent to TVR. All right, here we have some right triangles, and we want to know, or the question is, what values of A and B make these two triangles congruent? So I look at the hypotenuse, which is the one across from the right angle, and I know that they have to be congruent. So I would put B plus 40 equals 43. I subtract 40 from both sides, and B equals 3. That's the first part of it. This is a leg, and this is a leg, and they need to be congruent. So I have A plus 37 equals 40. I subtract 37 from both sides, and A also equals 3. And if I fill in 3 for A, 3 plus 37 is 40. And if I plug in 3 for B, B is 3. 3 plus 40 is 43. So that value of 3 for each one of those makes those two triangles congruent. Here's your first practice problem. It's asking what values of T and U make these two triangles congruent. If you're not sure what to do, go back and look at the example I just did for you. Here's another problem. What values of T and U make these two triangles congruent? There's my hypotenuse. There's my hypotenuse. I need to set them equal to each other. So I have 2T plus 37 equals 18T minus 43. I'm going to subtract 2T from both sides. That gives me 37 equals 16T minus 43. I add 43 to both sides, which gives me, add 43, and I get 16T equals 80. When I divide both sides by 16, I get T equals 5. Now I need to do U. I need to set the legs equal to each other. So I have 5. Let me get a smaller pen. 5U equals U. Practice problem 2. What values of T and U make these two triangles congruent? What values of V and W make these two right triangles congruent? Well, if you notice, I have a W and a V here, a W and a V here. On this hypotenuse, I only have a V, and on that hypotenuse, I only have a V. So I'm going to have to solve for V before I can solve for W. So let's start with V. I have 9V minus 27 equals 6V plus 6. I subtract 6V from both sides, which gives me 3V minus 27 equals 6. Add 27 to both sides. 3V equals 33. When I divide both sides by 3, I get V equals 11. Now I'm going to put V equals 11 right up here, and then I'm going to go ahead and erase the other. Alright, now that I know that V equals 11, I can start solving for W. I have W plus 2 times 11 is 22 plus 35 equals 7W plus 11 minus 20. I'm going to combine my numbers together. I have W plus 57 equals 7 minus 9, 7W. I'm going to subtract 1W from both sides. I end up with 57 equals 6W minus 9. Add 9 to both sides, and I get 6W equals 66. divide both sides by 6, and I find that W also equals 11. So V equals 11 and W equals 11. Your final practice problem says what values of P and Q make these two right triangles congruent. Remember, go back to the previous problem if you aren't sure how to do it, and watch how I do it again. So where are you after watching this? Are you, I don't get it? I sort of get it. I got this, or I'm so good I can teach this. Now remember, we really want you to sort of get it, but the best is I got this, and hopefully some of you are good enough you can teach this. And yet again, we come to the end of another lesson. Bye.